In the autumn of 1984, the massive factory floor at Port Talbot in Wales fell quietly still, leaving behind tens of thousands of unsold beige boxes that were supposed to redefine British industry. Just 2 years earlier, the Dragon 32 had launched with immense ambition, backed by the Welsh Development Agency. It commanded a premium $199 price tag, boasted a proper typewriter-style keyboard, and secured prime shelf space in major high street giants like Boots and Dixon's during the crucial Christmas rush of 1982. But its sudden collapse left a region without the manufacturing computing revival it was promised. It stranded local workers, and it abandoned a dedicated base of British bedroom coders who suddenly found their machines unsupported by the major software houses. A machine built to look and feel more professional than its rubber-keyed rivals was ultimately discarded by the very market it tried to elevate. The paradox is that the Dragon 32 did not fail because Wales forgot how to build machines. It failed because the British market had already decided that a computer without an ecosystem was just a plastic box. Every week, we tell the stories of British machines, platforms, software houses, and high street shops that once taught the country what the future felt like and what happened when the market moved on. Subscribe if that history matters to you. The story of the Dragon 32 begins not with nostalgia, but with a specific ambition. In a Welsh toy factory in 1982. The story of the Dragon 32 begins not in a traditional computer laboratory, but in a toy factory in Swansea, Wales. By early 1982, the British public was rapidly waking up to the microcomputer revolution. A home computer, a machine sold for household use, often connected to a television and loaded with software from tape, was no longer a niche hobbyist tool. It was becoming a high street necessity. In Cambridge, companies like Sinclair and Acorn were already battling for control of British living rooms and classrooms, promising parents that these beige and black plastic boxes were the definitive key to their children's future. For Metoy, a venerable British manufacturing company, famous for producing Corgi die-cast toy cars, this sudden digital shift presented a terrifying problem. The traditional toy market was shrinking. Children were increasingly fascinated by electronic games and screens, leaving perfectly engineered die-cast metal vehicles untouched on shop shelves. Metoy needed to pivot to survive, and they needed to do it quickly. They formed a new subsidiary, Dragon Data, with a singular, desperate objective: to build a British home computer that could capture the lucrative family market before the established technology giants locked them out completely. But Dragon Data faced a severe structural hurdle. The British tech market in 1982 was moving at an unforgiving pace. Designing a computer architecture from scratch, testing the circuit boards, and writing an operating system, the core software that manages the machine and lets other programs run, usually took years of intense research and development. Dragon Data did not have years. They had months. If they missed the crucial 1982 Christmas retail window, they feared the market would be entirely absorbed by Sinclair's highly anticipated ZX Spectrum and the Acorn-built BBC Micro. This corporate urgency at Metoy coincided with a much larger, more profound economic ambition in Wales. Heavy industries like coal and steel, which had defined the region for generations, were shedding jobs rapidly. Local authorities were desperate to replace these vanishing manual roles with modern, clean, high-tech manufacturing. The Welsh Development Agency, a government-funded body tasked with stimulating the local economy, saw Dragon Data not just as a company trying to sell a product, but as a lifeline for a struggling workforce. They provided substantial financial backing, transforming a risky corporate pivot into a major regional technology project. The factory floor in nearby Port Talbot was cleared. Wales was going to build computers on a massive scale. For the local workforce, the shift was staggering. A region historically defined by heavy industry was suddenly tasked with assembling printed circuit boards, soldering delicate components, and testing memory chips. The state backing gave Dragon Data an aura of invincibility. They were not a small startup tinkering in a garage. They were a heavily funded industrial operation with a serious, dedicated manufacturing pipeline. However, to meet their impossible high street deadline, the engineers at Dragon Data had to make a pragmatic, fateful decision: Rather than inventing a new architecture, they looked across the Atlantic. They based the Dragon 32 around a reference design produced by Motorola, an American chip manufacturer. Specifically, they chose the Motorola 68009E processor, the main chip that performs calculations and executes instructions. It was a highly advanced piece of silicon, arguably the most powerful 8-bit processor of its generation, capable of handling complex data far more efficiently than the older chips used by their British rivals. But by choosing this off-the-shelf design to save time, Dragon Data ended up building a machine that was internally almost identical to an existing American computer, the Tandy TRS-RD color computer, widely known as the Coco. This technical shortcut solved the time problem brilliantly. It bypassed the brutal, multi-year process of engineering a custom motherboard. They simply licensed a version of Microsoft Basic, altered a few minor software routines, and wrapped the entire system in a rugged, highly professional-looking beige case. It gave the workers in Wales a tangible machine to build, but it also silently embedded a fatal flaw into the foundation of the computer. A home computer is not simply a plastic box of soldered components. It requires an ecosystem, the network of users, developers, publishers, magazines, and accessories that make a platform valuable. In 1982, the British bedroom coding scene was already speaking very specific languages. The teenagers writing games on their bedroom desks, and the software houses springing up in cities like Manchester, Sheffield, and London were focused heavily on the Z80 processor inside Sinclair's machines, or the 6502 processor powering the BBC Micro. The Dragon's Motorola 68009E chip was technically superior, but it was an alien language in the UK market. For a British programmer, writing original software for the Dragon meant learning an entirely new architecture for a machine that did not yet have a guaranteed audience. Yet in the frantic summer of 1982, these software ecosystem concerns were entirely invisible to the executives. The focus was purely on production speed. Inside the Port Talbot facility, the atmosphere was charged with a sense of historical momentum. This was a regional public relations triumph. Workers who might previously have faced unemployment were now boxing up the future. The sheer scale of the operation gave Dragon Data a massive advantage over smaller, struggling British startups that were desperately trying to secure factory time in the Far East. Dragon owned their supply chain. They had the capital. They had the workforce. By August 1982, the production lines were running at full capacity, churning out thousands of units just as the vital retail window began to open. The blueprint was ready, the factory floor in Port Talbot was cleared, and Wales was about to ship its answer to Cambridge and Sinclair. In August 1982, the Dragon 32 officially entered the British market. The price was £190. To understand why this machine immediately commanded attention, one must look at what it was sitting next to on the shop shelf. The dominant conversation in British computing that summer was the Sinclair ZX Spectrum. The Spectrum was cheaper and it was brilliant, but it possessed a dead flesh, rubber keyboard that felt notoriously imprecise. The Dragon 32, by contrast, offered a full-stroke, proper typewriter-style keyboard. For a British parent walking into a high-street electronics shop, a place where families first encountered the digital future in person, often surrounded by stacks of televisions and hi-fi systems, that physical difference was profound. A rubber keyboard felt like a disposable toy. A mechanical keyboard felt like a serious investment in a child's education. The Dragon 32 was housed in a large, rugged, beige casing that made it look less like a bedroom gadget and more like a terminal that belonged in a modern office. The 32 in its name referred to 32 kilobytes of RAM. Memory, the fast temporary storage a computer uses while programs are running. In 1982, 32 kilobytes was a vast, reassuring number, double the memory of the entry-level ZX Spectrum and equal to the much more expensive BBC Micro. But a well-engineered plastic box is entirely useless if the public cannot buy it. The true breakthrough for Dragon Data was not just manufacturing, it was distribution. They achieved something incredibly difficult for a new technology company. They secured massive retail presence on the British High Street. The Dragon 32 appeared in the windows of Dixon's, on the shelves of Curry's, and critically, inside Boots. Today, Boots is primarily a pharmacy, but in the early 1980s, Its larger branches were major retailers of home electronics and audio equipment. Placing a computer on a boot shelf meant putting it directly in the path of parents doing their ordinary weekend shopping. The computer was no longer hidden away in specialist hobbyist catalogs. It was sitting under the bright lights of the high street alongside hair dryers and cassette recorders. For the first time, a machine built in a Welsh valley was standing shoulder to shoulder with Cambridge engineering and global consumer electronics, capturing the attention of the mainstream British public. When a family brought the Dragon 32 home and plugged it into their living room television, it booted instantly into Microsoft Extended Color Basic. Basic, a programming language that allowed users to type commands and write their own software, was the absolute standard of the era. The version licensed for the Dragon was fast, logical, and highly capable. A child could open the heavy, well-bound manual that came in the box, type a few lines of code, and immediately see text loop across the screen. It delivered exactly the educational promise that parents had paid $199 for. This combination of a professional appearance, high street availability, and a seemingly powerful architecture turned the Dragon 32 into a formidable contender as the crucial Christmas market of 1982 approached. Inside the Port Talbot factory, the scale of the operation was staggering. The Welsh Development Agency's gamble appeared to be paying off spectacularly. Production lines were running relentlessly to meet the retail orders. Lorries full of boxed computers were leaving Wales daily, distributing the beige machines to high streets from Glasgow to London. Dragon Data was suddenly a major employer, proving that a region scarred by the decline of heavy industry could successfully mass-produce complex digital hardware. The initial software library, while small, was growing. Because the Dragon 32 shared its internal architecture with the American Tandy Coco, a few software titles could be easily ported across the Atlantic. Early adopters could buy a cassette tape, magnetic tape used by many home computers to load and save programs, put it into a standard tape recorder, connect it to the Dragon, and load a game. The loading process involves screeching audio data, transferring into the machine's memory, a ritual that defined British home computing in the 1980s. By the end of its launch year, the Dragon 32 looked like an unstoppable force. It had bypassed the notorious production delays that plagued Sinclair. If a parent went into a shop with 100 ton, they could walk out with a Dragon 32 that same afternoon, whereas ordering a Spectrum often meant waiting months for delivery. This physical availability drove immense early adoption. The machine had established a foothold in the most fiercely contested technology market in the world. It had the backing of government money, a dedicated factory, and a rapidly growing user base of enthusiastic British families. It felt for a brief moment as though Wales had built the definitive British microcomputer. The brand had found its audience on the high street, but the market had not yet shown how quickly a bedroom habit could change. By early 1983, Dragon Data was no longer just a defensive pivot by a traditional toy manufacturer. It was a dominant force in British home computing. The momentum generated during the crucial Christmas retail window of 1982 had transformed the Dragon 32 from an ambitious Welsh experiment into a high-street staple. At its peak, the Port Talbot factory was operating at a relentless pace, producing tens of thousands of units to satisfy national demand. Delivery lorries carrying pallets of the heavy beige boxes became a regular sight on the M4 motorway, distributing the hardware to branches of Boots, Dixon's, Curry's, and independent computer shops across the United Kingdom. For a brief, glorious window, it was one of the fastest-selling microcomputers in Britain, capturing the attention of a public desperate to join the digital revolution. The physical experience of using the Dragon 32 felt genuinely premium. The keyboard, with its proper mechanical travel, encouraged actual touch typing, offering a stark contrast to the dead-flesh membrane surface of the Sinclair ZX Spectrum. When a family bought a Dragon 32, they were not simply buying a piece of consumer electronics. They were purchasing a promise of technological literacy. In a British living room where one computer might serve the whole family, the right machine did not merely run software. It decided who first saw code move on a screen, who discovered games as systems, who imagined work beyond the high street, and who felt that the future had finally entered the home. Children sat on patterned carpets, staring at analog television sets. typing commands across the bright green background that became the machine's visual signature. The true measure of a platform's strength in 1980s Britain was not just the hardware on the desk, but the paper on the magazine's shelf. In 1983, the ultimate validation arrived, the launch of Dragon User magazine. To walk into a W.H.E. Smith or John Menzies and see a dedicated monthly publication for your machine was proof that you had backed a living ecosystem. The magazine provided news, hardware reviews, and crucially, pages of type-in software listings. A teenager in a suburban bedroom could spend a rainy Sunday afternoon manually copying hundreds of lines of basic code from the magazine pages into their Dragon 32. If they made a single typing error, the program would crash, forcing them to comb through the text to find the mistake. This painstaking, frustrating ritual was exactly how a generation of British youth learned the underlying logic of software. The magazine also carried mail-order adverts from newly formed software houses, offering games on cassette tapes that could be delivered directly by the postman. The process of loading these games, connecting a standard cassette recorder, typing a command, and listening to the screeching audio data as the television screen displayed the flashing letters S for search and F for found, became a shared national habit. For the Welsh Development Agency, the Dragon 32 was a spectacular vindication. The strategy of replacing declining heavy industry with clean, modern technology manufacturing appeared to be an unmitigated success. Politicians and executives toured the busy Port Talbot facility, pointing to the sterile assembly lines and testing benches as the definitive blueprint for Britain's industrial future. The scale of the operation was immense. Dragon Data outgrew its original structure, spinning off from its parent company, Metoy, to become an independent corporate entity. Investment poured in from major institutions. The management team, buoyed by the phenomenal retail numbers, began to plan an aggressive expansion. They prepared a push into the export market, aiming to sell the Welsh machine across Europe and beyond. They also finalized the design for the next hardware iteration, the Dragon 64, which doubled the memory and added communication ports, intended to break into the lucrative educational and small business markets. The ecosystem, the vital network of users, developers, magazines, and retailers that makes a platform valuable, seemed to be solidifying rapidly around the powerful Motorola processor. It felt as though Wales had successfully built a permanent pillar of the British computing establishment. In the summer of 1983, the ecosystem around the Dragon 32 reached its absolute zenith. The machine was no longer just a physical product manufactured in Wales. It had become a cultural fixture within the British technology landscape. For independent software developers, the bedroom coders, teenagers, and small startups driving the British gaming boom, the rapidly expanding user base was becoming impossible to ignore. A home computer could only survive if it had software, and the Dragon was finally building a library. Publishers like Microdeal built highly profitable businesses, largely by taking American software originally written for the Tandy Coco, slightly modifying the code to suit the Welsh machine, and releasing it on cassette tape for the British market. When a British teenager walked into a local computer shop or a branch of W.H. Smith, they no longer had to search for Dragon software hidden in a corner. The machine had earned its own dedicated shelf space. Colorful cassette inlays promised arcade action, text adventures, and educational software, proving that the platform was alive and supported. Network effects, the pattern where a product becomes more valuable as more people use it, appeared to be locking in favor of Dragon Data. Because so many machines were being sold, more magazines gave them page space. Because magazines provided page space, more developers wrote software. Because more software was available on the high street, more parents felt confident spending $199. The community of users became highly organized. Independent user groups formed across the United Kingdom, holding local meetings where enthusiasts would swap code, discuss hardware modifications, and share tips on getting the most out of the Motorola 6809E processor. Computer fairs, bustling, crowded weekend events held in school halls and leisure centers, featured rows of trestle tables where independent programmers sold Dragon games directly to users, often packaged in simple plastic bags with photocopied instructions. It was a thriving physical manifestation of a digital ecosystem. Inside the boardroom, the ambitions scaled to match the retail numbers. Dragon Data was spun out from Metoy, becoming an entirely independent corporate entity. It attracted massive financial investment, most notably from the Welsh Development Agency and Prutech, a venture capital arm of Prudential. This was serious institutional money, validating the belief that Britain had produced a home computing giant capable of matching Sinclair and Acorn. The company immediately began planning an aggressive export strategy, aiming to sell the Welsh machine across European markets, particularly Spain and Scandinavia. Simultaneously, they prepared to launch the Dragon 64, a more expensive, upgraded machine featuring 64 kilobytes of memory and built-in communication ports, designed specifically to break into the lucrative educational sector in the small business market. At this moment, the Port Talbot factory stood as a monument to modern British manufacturing. It was proof that a region could successfully transition from the heavy, soot-stained industries of the past to the sterile, high-tech assembly lines of the future. The sheer volume of beige boxes moving down the conveyor belts and onto delivery lorries suggested a permanent victory. The Dragon 32 had the high street presence, it had the mechanical keyboard that parents trusted, it had the government backing, and it had a growing library of cassette software. To the casual observer checking the electronics displays in a British high street window, Dragon Data looked like a permanent pillar of the microcomputer revolution, poised to dominate the next decade of British technology. Dragon Data looked like a new British technology empire. But that same rapid scale would soon become the trap. The first crack was almost invisible. It did not happen on the bustling factory floor in Port Talbot, and it did not happen in a corporate boardroom. It happened in British bedrooms as teenagers sitting on patterned carpets stared at their television sets and realized their $199 investment was struggling to keep up. The Dragon 32 was built around the Motorola 689E, a processor that was fast, highly capable, and widely respected by serious programmers. But a home computer, a machine sold for household use and connected to a television, is not judged solely by its central processing speed. It is judged by how it looks, how it sounds, and how it plays. The fatal flaw of the Dragon lay in a companionship. The Motorola 6847 video display generator, the hardware responsible for drawing graphics on the screen. By the rapidly evolving standards of 1983, this graphics chip was already aging poorly. In its default text mode, it could only display blocky, uppercase, black letters against a harsh green background. More critically for the British market, it lacked hardware sprites, dedicated, easily movable graphical objects that allow games to animate smoothly without overburdening the main processor. For a small business owner typing a basic invoice, this was perfectly acceptable. But for a British teenager trying to play a fast-paced arcade conversion, it was a glaring limitation. The games written for the Dragon often required severe color compromises to achieve high resolution, resulting in screens that looked washed out, blocky, and visually inferior to the vibrant colors of the Sinclair ZX Spectrum or the smooth, sprite-driven action of the Commodore 64. This technical bottleneck immediately fractured the ecosystem. A platform needs users to attract software, but it must have a constant stream of new, exciting software to keep those users engaged. The major British software houses, operating out of small, cramped offices in London, Manchester, and Sheffield, were businesses with limited time and strict budgets. Writing a game took months of intense labor. If a developer had to choose between programming for the massively popular, graphically capable Spectrum or the text-heavy green-screen Dragon 32, the commercial decision made itself. Network effects, the pattern where a platform becomes more valuable as more people use it, began to work in reverse. Walk into a branch of W.H. Smith or John Menzies in late 1983, and the shift was physically visible on the shelves. Earlier in the year, the Dragon 32 had commanded prominent, dedicated shelf space. Now the cassette tapes bearing the Dragon logo were quietly being shifted to the lower, dustier racks to make room for rows of colorful Spectrum and Commodore game inlays. In the multi-format computer magazines of the era, the page counts told a similar story. While the dedicated publication Dragon User fought valiantly to keep the community alive with type-in listings and technical guides, mainstream computing magazines began to allocate less space to Welsh machine reviews. If a platform was not being discussed in the monthly press, to the broader British public, it simply ceased to exist. Sensing this shift, Dragon Data attempted to respond with hardware. In late 1983, they released the Dragon 64. It was physically almost identical to its predecessor, housed in a slightly darker gray case, but it doubled the memory to 64 kilobytes and added an RS-232 serial port, a communication interface that allowed the machine to connect to modems and external printers. The strategy was clear. If the bedroom gamers were leaving, the company would pivot towards the lucrative school computer market and small businesses. But this pivot collided with a brutal market reality. The classroom was already aggressively defended territory. The British government's computer literacy schemes heavily subsidized the Acorn-built BBC Micro, cementing its status as the default school computer. A head teacher was unlikely to abandon the BBC Micro, with its vast library of educational software and television tie-ins, for a repurposed Welsh games machine. Simultaneously, the small business market was beginning to demand serious disk drives and professional word processing software, a space soon to be entirely dominated by the Amstrad PCW. The Dragon 64 did not solve the fundamental graphical limitations, and it arrived too late to alter the narrative. Worse, the broader high-street technology market had entered a vicious price war. Sinclair had drastically slashed the price of the ZX Spectrum, and Commodore was ruthlessly discounting the C64. The original $199 price tag of the Dragon 32, once seen as a premium investment in a proper mechanical keyboard, suddenly looked entirely uncompetitive for a system with a shrinking software library. The physical machine was as robust and reliable as ever, but the market had already decided that reliability was no longer enough. By the end of the 1983 Christmas shopping season, the structural weakness of the Dragon 32 had become impossible to hide. The high street, which had been the engine of Dragon Data's initial triumph, is a ruthless environment. Retailers like Boots, Dixon's, and Curry's allocated their limited shelf space based entirely on momentum. If a machine had the latest games and the highest demand, it stayed in the window. If it stalled, it was quickly relegated to the discount bins. As British parents and teenagers chose the cheaper Sinclair ZX Spectrum or the graphically superior Commodore 64, the retail orders for the Dragon abruptly stopped. This created an immediate, catastrophic crisis for the massive manufacturing operation in Wales. The Port Talbot factory, previously hailed as a shining example of modern British industrial strategy, suddenly transformed from an asset into a fatal liability. Manufacturing at scale is incredibly profitable when a company is clearing its inventory. But when the market turns, a large factory becomes a financial black hole. Parts had been ordered months in advance. Assembly lines were running. Warehouses were rapidly filling up with tens of thousands of beige boxes that the high street chains no longer wanted to buy. The Welsh Development Agency and Prudtech, the institutional investors who had poured millions into the operation, looked at the mounting inventory and the collapsing software support, and they panicked. The ecosystem had broken. Without the software, the users stopped buying the hardware. Without the users, the software houses entirely abandoned the Motorola 6809E processor. A home computer is only as valuable as the code it can run, and the Dragon was starving for code. In June 1984, less than 2 years after the machine had triumphantly launched, the inevitable occurred. Dragon Data collapsed into receivership. The human consequence in Wales was immediate and devastating. The factory floor at Port Talbot was shut down. Hundreds of local workers, who had been promised that their transition from the declining traditional heavy industries into clean, high-tech manufacturing was the permanent future of the region, were suddenly made redundant. The grand political vision of Wales as a new Silicon Valley was reduced to padlocked gates and silent assembly lines. The physical manifestation of this failure was staggering. Reports from the Times suggested that over 40,000 unsold computers were left sitting in warehouses, gathering dust. For the British users who had invested their 119 dus, The collapse was a harsh lesson in the brutal reality of platform economics. A teenager might turn on their machine, type in a basic command, and find that the hardware still worked perfectly. The mechanical keyboard was still excellent, but the world around the machine had died. If they walked into a local electronics shop, the Dragon cassette tapes were gone. The dedicated computer fairs stopped hosting Dragon software stalls. The machine in their bedroom had become a technological island, cut off from the vibrant, rapidly evolving British computing culture. In a strange final footnote to the corporate story, the remains of Dragon Data were eventually bought by a Spanish startup named Eurohard. They purchased the rights, the blueprints, and the massive backlog of unsold stock, moving the entire operation out of Wales and into Spain. They attempted to sell the machines to the Spanish educational market and released a few minor hardware iterations. But it was a desperate, doomed effort to revive a platform that had already lost its momentum. By 1987, Eurohard had also collapsed, and the Dragon name disappeared permanently from the commercial market. But for the British market, the story had already ended in 1984. The failure of the Dragon 32 was not a failure of physical engineering. It was a failure to understand that building a computer was no longer enough. A company had to build an ecosystem, and it had to keep the bedroom coders happy. The factory gates closed. The assembly line stopped. The high street shelves were cleared. The software houses moved on. The magazine adverts vanished. The Welsh hardware dream ended. The logo remained on a few European shelves. The ecosystem in Britain was already gone. When the Spanish venture Eurohard collapsed in 1987, the Dragon name was permanently erased from the commercial technology register. The grand ambition of building a Welsh computing empire was dismantled, leaving behind only unpaid debts, locked factory gates, and the fading memory of a regional industrial promise. The corporate entity vanished entirely, but hardware, particularly hardware built with the rugged, over-engineered solidity of the early 1980s, takes a remarkably long time to die. Decades after it lost its high street shelf space, the Dragon 32 has found a second, entirely different life within the British preservation and vintage computing community. If you visit the National Museum of Computing at Bletchley Park, or attend a retro computing fair in a suburban British leisure center, you will inevitably find a Dragon 32 sitting on a trestle table. Its thick beige casing has likely yellowed slightly with age, but the physical presence of the machine remains commanding. The mechanical typewriter-style keyboard, the very feature that once convinced British parents to part with 199, still offers the same satisfying, deep travel that the rubber keys of a ZX Spectrum could never match. These surviving machines are maintained by a small, fiercely dedicated community of enthusiasts. Through forums and modern online archives, this network of collectors continues to trade original cassette software, repair aging power supplies, and preserve the deep technical documentation that once shipped in heavy ring binders. The ecosystem that Dragon Data failed to sustain commercially in 1984 has essentially been artificially reconstructed by historians and hobbyists. Modern emulators, such as the widely respected XROR software, allow anyone to run the Dragon's operating system on a contemporary laptop, perfectly recreating the harsh green screen and the blocky uppercase text mode that define the original experience. But we do not remember the Dragon 32 simply out of a vague, affectionate nostalgia for beige plastic and cassette loading screens. We remember the Welsh machine because it stands as one of the clearest, most brutal early warnings about the fundamental nature of digital platforms. The Dragon 32 passes the ultimate historical test. It proves why ecosystems matter more than hardware. The machine was not a failure of engineering, and it was certainly not a failure of manufacturing. The Welsh Development Agency and the workers at Port Talbot did exactly what they promised to do. They built a robust, highly capable piece of consumer electronics, and they produced it at a massive scale. The tragedy of the Dragon 32 is that it was introduced into a British market that was rapidly discovering that hardware was only half of the equation. By 1983, a home computer was no longer just a standalone tool. It was a platform that required constant external validation. It needed a steady stream of new games from independent software houses. It needed heavy page counts in multi-format computer magazines. It needed teenagers to talk about it in school playgrounds. And it needed shop managers at Boots and Curry's to keep it in the display window. The Dragon 32 died because it could not secure this invisible architecture of support. The superior processing speed of its Motorola 6009E chip meant absolutely nothing when the teenagers writing software in their bedrooms preferred the graphical capabilities of the Commodore 64 or the immense guaranteed audience of the ZX Spectrum. This dynamic, where a perfectly good machine is starved to death by a lack of developer support, is not a relic of the 1980s. It is the exact same systemic force that would later destroy the BlackBerry, doom the Windows Phone, and force the collapse of countless modern platforms. The Dragon 32 simply suffered this fate decades before the term App Store was ever invented. It was a victim of the network effect, crushed by the gravitational pull of larger, more vibrant ecosystems. The bitter irony and the surprise footnote to this entire story is that the core technology inside the Dragon was fundamentally sound. The Motorola processor that powered it was an elegant, highly advanced piece of silicon that many programmers adored. Today, a modern homebrew coding scene actually writes new software for the Dragon 32, finally unlocking graphical tricks and programming routines that the rushed developers of 1983 never had the time to discover. They are proving 30 years too late what the machine was truly capable of. The story of Dragon Data is a profound lesson in the limits of traditional industrial ambition. The British government and regional authorities looked at the decline of coal and steel, and they believed that building computers in a massive factory would secure the future of the Welsh economy. They successfully built the factory, they successfully shipped the hardware, but they fundamentally misunderstood that the value of a microcomputer was no longer generated on the assembly line. It was generated in the bedrooms, the software houses, and the magazine pages that surrounded it. They built a perfect isolated island in a market that demanded a connected continent. Somewhere in a British loft, a Dragon 32 still rests inside a softened cardboard box, its heavy mechanical keys silent, waiting for a cassette tape that once tried to turn a Welsh industrial promise into a high-street digital reality. See you in the next one.